Lecture we will learn the differentiation of hyperbolic functions. Remember, we have reviewed hyperbolic functions when we studied the section on different types of functions. So as a reminder, a sine hyperbolic or sinh x is defined as e to the x minus e to the negative x over 2, as you can see here. And cot x, which is hyperbolic cos, is defined as ex plus e to the negative x over 2. Then tan x, which is hyperbolic tan, is divided by sinh x divided by cot x, right? And then similarly the others, the sich x is 1 over cos x, right? And you can see how these functions are. The sinh x is like this. Cot x is here, and if you do 1 over this, you can see when these going to infinity, this one is going to 0. At 1, this is 1, right? So you can see why this one is sich x, the plot of a sich x function. Okay, and this is sinh x, and this is cosich x, and this is 1 over sinh x, and you can see again when it's going to 0, positively it's going to infinity. 1 over that function value is going like this, and similar to this one here. And then finally we have tan x, which is sinh x divided by cot x. These are the plots. Now we can easily derive the derivatives of all these functions. So for example, d over dx of sinh x is d over dx of the formula for sinh x, or the definition of sinh x, and that involves exponential functions. So of course the derivative of ex is ex, and derivative of e negative x is negative e to the negative x. So when you plug that in, we see that derivative of sinh x is cot x. Similarly, you can derive the derivatives of all the other functions, basically doing the derivative operations on their definitions in terms of exponential functions and then substituting back. And what we see is these formulas look similar to what we have for derivatives of trigonometric functions. So derivative of sinh x is cot x. A derivative of cot x is not negative sinh x though, it's positive sinh x, unlike trigonometric function where derivative of cos x is negative sin x. Derivative of tan x is sec square x, okay, very similar to trigonometric one where derivative of tan x is secant square x, and derivative of cot x is negative cosec square x. Okay, so again, look at the sign here, and then sec x, derivative of that is negative sec x tan x. So negative sign shows up compared to in the trigonometric one, and similarly cot x, derivative of that is negative cot x cot x. Derivative of cosec x is negative cosec x cot x. Okay, and now, so this was about differentiation of these, and using this, and of course using, for example, the chain rule, then knowing this table, you can find the differentiation of functions of this type. All right. Now, the inverse functions. So we know inverse functions, how inverse functions of any function is defined. If you have a mapping which maps x to y, and the mapping is one-to-one mapping and onto, that means it's a bijective function. It is injective and surjective. Bijective function, then its inverse exists. Inverse means if you look at the function which maps x to a y value, if you just flip it in such a way that you can see for a given y value, now basically the x-axis will be the y-axis, and from the y you can plot the x values, right? I mean, that's how inverse functions are obtained. So this table gives you domain and range on these inverse functions, inverse hyperbolic functions, and the plots of these are given here. These can be derived by looking at the plots of the original hyperbolic functions. Okay, and then we can obtain the derivatives of these inverse functions. As an example, so we have to find the derivative of sinh inverse x. So let's say y equals sinh inverse x, and we want to find out dy over dx. So y is sinh inverse x means sinh y is equal to x. Now take the derivative with respect to x of both sides. On the right, we are getting 1. On the left, we basically apply the chain rule. Derivative of sinh y is cos y, and then dy over dx. That's the chain rule. So therefore, dy over dx equals 1 over cos y. Okay, so we know that cos square y minus sinh square y equals 1, right? It has a minus here, not plus, as is the case in trigonometry, which is the Pythagoras theorem. But in hyperbolic functions, we have a negative sign here. Okay, so therefore cos y is equal to square root of 1 plus sinh square y. And why are we trying to replace cos in terms of sinh? Because we have x as a sinh inverse. And therefore sinh y is x. So we want to have cos y in terms of sinh y, because then it'll have an x in it. So dy over dx, which was 1 over cos y, 1 over cos y, it is equal to 1 over square root of 1 plus sinh square y. And it is equal to 1 over square root of 1 plus x square, because sinh y equals x. So similarly, we can derive the derivatives of each of these functions. And the table is giving us the results.